Hello everyone, I am Srikanth. I would like to demonstrate the usage of Weka using United States Congressional Voter Database. Using this data, I would like to build a decision tree to classify whether a voter is a Republican or a Democrat based on the views of voter on different issues like immigration, duty-free imports, and defense spending. So now let us see how to import this data into Weka and classify it. Okay, let me load the data into Weka. I'm opening my file. I'm selecting the vote.arff file from my data folder in Weka. Let me open it. The data is open now. The data contains 17 variables like views of voters on religious groups in schools, anti-satellite test bans, missiles, immigration, and educational spending. The one thing we will consider here is we want to build a decision tree on how to classify a voter as Republican or a Democrat basing on the different views available here. Now let me give a brief overview of different tabs in Weka. The pre-process tab is where you select the data. The classify tab is where you can select your algorithm which you want to apply on your data. The cluster tab is mainly used for clustering problems. Associations like a priori and filtered associator. Selected attributes tab gives us attributes that are important for the classification. For this example, the attributes that are important are adoption of budget resolution, immigration, and corporation cutback. Visualization tab is where you can get a 2x2 plot of all the variables that is available. Now let me apply the classification algorithm for the data that was loaded. So let me go to the classify tab and choose the J48 algorithm, decision tree algorithm under the trees subfolder. I'm choosing J48. We have different options available in the algorithm, that is use the training set where the 100% of the data used for training. The next thing is supply test set where we supply the test data. The next thing is cross validation where we can specify the number of folds that can be used that should be used for cross validation. The thing that we are generally going to use is percentage split where we split the training and test data. Let me mention this as 70 over here, that is 70% of the data used for training and 30% of the data used for testing. Now let me apply the decision tree algorithm and look over the results. I'm starting the algorithm and here you can see that number of instances is 435 and you can see all the attributes over here, those are 17. Here you can see the decision tree that is prone. The number of leaves are 6 and the size of the tree is 11. The number of instances that are correctly classified is 125 and the accuracy is 96.15. Now let us look at the confusion matrix over here. The confusion matrix says that if a person is Republican, the probability, the number of instances that the classification algorithm has correctly classified the Republican as Republican is 50, and the times it has predicted Republican as a Democrat is 2. One more thing is I would like to add in the prone tree is where you can see the classified number of rows and misclassified number of rows. Now let us see the different properties of decision trees. By clicking on the white space over here, you can see the different properties of decision trees. They are confidence vectors, minimum number of objects, number of decimal places, and number of folds. Now let us see about the confidence vector. The lower the value of the confidence vector, the higher is pruning in the decision tree. When we have seen the example before, we have considered the confidence vector to be 0.25. Now let's make the confidence vector to be 0.05 and let's see how this affects the pruning. I'm selecting the confidence vector to be 0.05, click OK, and let's start the model again. You can see that there is not much change for this model in the pruning, but you can see the accuracy of the model has increased. Now the number of correctly classified instances has increased to 125 and the accuracy is 96.1. And the number of applicants that are correctly classified has increased by 1 to 51. So let me apply neural networks on the same data. A neural network is a network of different weights connected to each other. Neural network algorithm in Weka is available under functions under multi-layer perceptron. Let me select it and apply the percentage split of 70 and let me start the process. So a neural network has got a bottoms-up approach. You can see the node 0 is a Democrat and node 1 is a Republican, and you can see all the weights of the nodes that has been created from the attributes. As from the information, you can see the number of instances of 435, the attributes are 17, and you can see the number of classified instances is 125, the accuracy is 96.15, and the number of Republicans that are classified correctly are 51 and correctly wrongly are 1. The decision on when to use a neural network or a decision tree depends upon the data, and sometimes we even combine both algorithms to obtain better results.